Hello, mentors. Let's talk about mission 2, which is get at least one comic in Kiliwa. So remember, we're in meeting 1, 20 comics, and we have this distribution. Mission 1 was 2 comics in Spanish, and mission 2 gets simpler in a one way because it's just 1 comic, and we'll see what happens. So again, this, as the previous video about mission 1, we don't want to show this to the students, but it's just for us to have a very solid understanding of what's behind the game. So just 1 will give you about 10, well, exactly 10% chance. So just picking 1 comic, very risky. Once you get to 2, you almost double probability, not quite, but 19%. And then you start growing, but less and less so. So for example, when you get to 14, the probability is already 92%, and then it just marginal growth, very, very small growth. So get at least 1 comic in Kiliwa. This is after playing the game that students find the smallest n that guarantees that the mission is accomplished. So students could maybe say 3, reasoning there's 3 languages, right? There are 3 types of things. So I gotta get these 3. This is, of course, invalid. It's incorrect, logically speaking, mathematically. So you would discuss what would happen, maybe even play around and experiment. So they'll see probably easily that 3 is not enough. Doesn't guarantee this probability. Actually, it's just not even 30%, because we have so few of K, right, of this language. That's gonna be really bad. Then they could say, they could kind of go bigger and say something like 15. And the reason it could be, it's a lot, right? Something like that. And it's just not possible that I'm gonna get this unlucky. I'm just gonna get the 15. Again, this is incorrect, right? So then we get into the mood of what's the worst case it could happen, right? Worst case scenario. And the worst would be getting 10 in English, and then 8 in Spanish, so 18. And then I run out of bad luck because I already got my obstacles to the mission. So the next draw, no matter what, is gonna be one of the Kiliwa language. So n equals 19. So this guarantees 100%. And it believes so because n equals 18, it's also not 100%. Why? Well, because I could be really in a really bad, 18, in really bad luck and do this. Very unlikely. So when you play the game, picking n equals 19 may not be the best strategy, unless you play another game that is really high stakes and you really want to accomplish the mission. But here, it's not the case. Then students discuss the probability close to 80%, right? So what's the best n to pick if I want 80% chance, of passing the mission? This is intuitive, so they don't have to calculate or compute abstract formulas for probabilities. That's not the goal of this mission, but more about intuition and experimental probability. Let's say students start with n equals 5 and they say, I think n equals 5 will give me 80% chance. So then what they could do is experiment. Let's say, for example, they play the mission 20 times. And then what way they do is pass x times, total would be 20. And then they would make sense of x and 20, and they would calculate what's x divided by 20, or what's the proportion. And if that gets close to 80%, then, well, it's not a proof, but it's some experimental evidence, as they were doing science, right? That this n that they pick, it's good enough. What's going to happen is that if they pick n equals 5, here you can see it's close to 45%. So probably 9, right? Something like that. 9 out of the 20 would pass. So this X will probably be 8 or 9, something like that. Let's say 8. And so it's total no, and it's way below, right? So what do? Well, they experiment again. So it didn't work. So go high. And maybe then now they go with n equals 10, right? And what's going to happen, you never know, right? This is because this is probability. We're not certain that we're getting these numbers, but if they go with 10, they'll get close to 80 here. So they could even stop or go a little more. So the mathematical answer, the correct answer is 11, but it's good enough for the meeting that they get in the like in 10 or 13. So 10, 11, or 13 to me are pretty good values. Even 13, I mean, goes higher, goes more like 90%. So that may needs more checking. But what shouldn't happen, hopefully, is that they pick 17 and they, after experimenting, they're happy because that should be not be the case. So that's the gist of it. It's experimenting, it's experimental probability, no abstract computations, and just getting some intuition on that. In the next meeting, in meeting 2, we'll actually replay these missions in other contexts, and we'll also give them these graphs with the probabilities. So they still don't need to compute them, but make sense of them. But let's go slower. And in meeting 1, it's just the tip of the iceberg. It's just playing the game and asking these questions that will lead to these theoretical probabilities. Okay, so I hope you enjoyed the meeting and see you in the next video. Goodbye.